Proposition 16. For any triangle, when one of the sides is produced, the external angle is greater than each of the internal and opposite angles. Let ABC be a triangle and let one of its sides, BC, have been produced to point D. I say that the external angle ACD is greater than each of the internal and opposite angles CBA and BAC. For let the straight line AC have been cut in half at point E according to proposition 10, and BE being joined, let it have been produced in a straight line to point F, and let EF be made equal to BE according to proposition 3, and let FC have been joined, and let AC have been drawn through to point G. Therefore, since AE is equal to EC and BE to EF, the two straight lines AE, EB are equal to the two straight lines CE, EF respectively. Also, angle AEB is equal to angle FEC, for they are vertically opposite, proposition 15. Thus, the base AB is equal to the base FC, and the triangle ABE is equal to the triangle FEC, and the remaining angles subtended by the equal sides are equal to the corresponding remaining angles, according to proposition 4. Thus, BAE is equal to ECF, but ECD is greater than ECF. Thus, ACD is greater than BAE. Similarly, by having cut BC in half, it can be shown that BCG, that is to say ACD, is also greater than ABC. Thus, for any triangle, when one of the sides is produced, the external angle is greater than each of the internal and opposite angles, which is the very thing it was required to show. Proposition 17. For any triangle, the sum of two angles taken together in any possible way is less than two right angles. Let ABC be a triangle. I say that the sum of two angles of triangle ABC taken together in any possible way is less than two right angles. For let BC have been produced to D, and since the angle ACD is external to triangle ABC, it is greater than the internal and opposite angle ABC, according to proposition 16. Let ACB have been added to both. Thus, the sum of the angles ACD and ACB is greater than the sum of the angles ABC and BCA. But the sum of ACD and ACB is equal to two right angles, according to proposition 13. Thus, the sum of ABC and BCA is less than two right angles. Similarly, we can show that the sum of BAC and ACB is also less than two right angles, and further that the sum of CAB and ABC is less than two right angles. Thus, for any triangle, the sum of two angles taken together in any possible way is less than two right angles, which is the very thing it was required to show. Proposition 18. In any triangle, the greater side subtends the greater angle. For let ABC be a triangle having side AC greater than AB. I say that angle ABC is also greater than BCA. For since AC is greater than AB, let AD be made equal to AB according to proposition 3, and let BD have been joined. And since angle ADB is external to triangle BCD, it is greater than the internal and opposite angle DCB according to proposition 16. But ADB is equal to ABD, since side AB is also equal to side AD according to proposition 5. Thus, ABD is also greater than ACB. Thus, ABC is much greater than ACB. Thus, in any triangle, the greater side subtends the greater angle, which is the very thing it was required to show.